Hello and welcome back to part two of making our merge game in Godot 4. Today we are going to be focusing on one of the most powerful concepts in game development and computer science, object-oriented programming. Specifically, we're going to focus on classes and objects. In a merge game, you might have 50 different items: bread, meat, cheese, level 1, level 2. Beginner mistake is to write 50 different scripts for each item. That's a nightmare to manage. There's lots of copying and pasting that you might be tempted to do. Sometimes when you do that, you skip over things. Bugs emerge. Every single object is going to be a point of conflict. So instead, we're going to write exactly one script, and we call that a class. You might think of it like a blueprint. Then it's just a matter of plugging different data into that blueprint to create our actual game objects. The classic example they always give is a class is a blueprint for a car, and the object is a 2018 Ford Fusion. All right. So here in Godot, we're going to need to keep things organized. The first thing we're going to do is we're going to create a folder, and we are just going to name this. Oops. We're going to create this new folder, and we're just going to call it scripts. And now this is where all of our code is going to be found. The reason we do this is because if we're working on something in the game where we don't need to be looking at the scripts, we can just collapse the folder, and now we're not looking at them anymore. Additionally, we don't have to root through and look at different icons or file extensions to see, is this a script, is it not? It's just really important to keep things organized. There is something in game dev where you have to focus on how am I going to make things easy to access and readable to essentially future-proof your product, right? We don't want a scenario where you're 6 months in and you just can't find anything ever and you've got all this spaghetti code. We want to avoid that as much as possible. So always keep in mind, how can I future-proof my process? And that should always be your main consideration. All right, within our scripts, we're going to create a script. And this is just basically a chunk of code. Yours is going to default to GDScript. For this tutorial, we will be using C#. Now, that in mind, if you would like to use GDScript, you can. Just recognize the concepts will carry over, but the actual code written out may not. So we're going to call this merge item data. Now, a lot of times you just have merge item and the merge item data together in traditional programming. We're going to separate them, and you're going to be able to see why throughout this process, why that's easier. All right, create. Now you can see this here in the scripts. We're just going to double click on this, and if you set everything up right, it should boot up your Visual Studio or Visual Studio Code, and this is where we will actually be doing our writing. Now, the first thing that we want to do is we always, and this is good practice. Some people don't do it later on in their career or education, but good practice is to kind of get out your thoughts in your code first. We call this pseudocode. So what's going to go into a merge item, right? The first thing is its name. So we've got the item name. We've got the family it belongs to, right? We might have meat, dairy, vegetables, fruit. We've got the level, and this tells us what generation it's going to be in. We've got its texture, which is what tells us which is how it's going to look. And we are also going to include, this is a little bit of like recursion here, not quite recursion, but we're going to include its parent. And we can just point that to the parent's merge item data. Okay. Now, one other thing we're going to do with this is we're going to make what's called a global class. If I can spell. And we're going to call this, rather than a node, we're going to call this a resource. Now, this does something important. Back here in our editor, this is where we really get into interactive stuff where you can kind of just point, click, select things. And when we create a resource or a global script or an export variable, we can now access these in the editor. And this is where a game engine really comes together. We can essentially build on top of what we already have and just make it where it's a lot more interactive and easy to use. All right. I mentioned export variables. We're going to make these visible in the editor by saying export. For an item name, this is mostly just for our readability. It doesn't need to be too specific of data. And so in a case like this, a string is perfect. And we're going to initialize it by just calling it item name. And that's how it's going to show up in our editor. I will show you that here in a little bit. Okay. Our next thing is our family. Now with the family, this is where we need something that's very, set in stone. We don't want to accidentally misspell vegetable at any point in time. So we're actually going to make this what's called an enum value. Now, one thing I'm remembering is that you can't actually create enums this way. You're going to actually need to define it outside. So we're going to set this to a public enum. And it's okay if you don't fully understand this right now. I think sometimes with cases like this, we just want to get going because sometimes it just clicks after that. So the ones that we're going to do a meat item. Oh boy, this is not liking me right now. There we go. We're going to do meat. We're going to do fruit, vegetable, dairy. Now, if we ever want to change our options here, all we have to do is change it in one spot. So right here, instead of doing it that way, we're just going to create a public, and now rather than, it's going to be item family, and we'll call this just family equals, and we're just gonna we're not going to instantiate that actually. We're just gonna leave that as is. All right. Now this is where VS Studio and VS Code, this is where it really shines. Sometimes you can see it's got this predictive text. Now, I would recommend when you're first starting to not rely on this too much, as you really have to be careful. I mean, you see when I created this enum, it automatically started thinking I was going to have armor and swords. Sometimes this, I mean, it's just giving its best guess based off of context, and sometimes that's wrong. So you're going to want to be careful with that. Avoid using that more than you need to. All right. But you'll see sometimes it's accurate. Like in a case like this is exactly what we're going to be doing. So public texture. Now, each of these essentially are what we're creating, right? So an int, for example, has its own set of behaviors, just like what we're creating for merge items. Same with strings, same with texture 2D. And so by creating a resource, we're making it where this merge item data can be used across our editor and throughout our code by making it public. All right. And then the last thing here is, again, export public merge item data. And we're going to call this next level. Sorry, I should have clarified that. This is not its parent. In a way, it's descendant. And don't forget to end with a semicolon. All right, so that's all the data that we're going to need for it. Again, a lot of times you'd have this included in just something called merge item, but in this case, we're going to split it out, and you'll see why later. I will explain when we get there. Okay. All right, so now we are in a situation where we can create. Um, First thing, something important is anytime you create something in code you want to see in your editor, you're going to want to build your project first. And this basically just makes sure your code is good and it synchronizes it. All right, so now let's create a new folder. This folder we are going to call merge items. And this is where our data is going to live. We're going to create another folder, and this is going to be for our meat items. Now with folders, it's okay if you put spaces in there. The thing we're going to want to avoid putting spaces in is in your code. So I'll even just for consistency's sake, rename that. Okay. Now within meat items, this is where things really start to shine. Go to create new, and we'll go to resource. Now you're going to find that this merge item data that we just created is accessible. So we're going to select that, and we will just call this meat level 1. All right. Now that we have this created, you can see in our editor here, we have all this information about our meat item. Now, something I'm going to do really quick, I already have all of the image files available. And we are going to I'm just going to drag them over to our project. I'm going to include a link to these in the description as well. And so these should be accessible for you online. So just install it, or sorry, download the zip folder I'll include, and then you can just load them up in here so you don't have to create any of your assets. So we'll give this a second to load here. All right, we're going to move this just into our root folder. That's my mistake. I should have dragged it there from the beginning. All right, so we got our sprites here. And we're going down to meat. And we've got meat level 1. Okay. So our item name, we're going to call this bacon. And the family, because we made it an enum, we have this drop-down list. You can't misspell meat. You can't misspell anything. It's all in here. So we'll select meat. It's going to be level 1. And then for its image, we're just going to drag over this texture. And then next level, we're going to wait until we've created a meat item number 2, which just for the sake of demonstration, we'll just do really quick. And you can start to see how this turns into a really fast process, right? I have just now created another meat level 2. Now we can call this one sausage, meat family, level 2, texture, drag our meat level 2 in here. And now if we go back to meat level 1, we can drag this data we just made from meat level 2 and drop it into this next level folder. All right. Now we're going to be using that in our logic later to tell our meat how we're going to respond when we merge it with another one. Okay, so now we have our data. We're going to need an actual physical object to represent it, though. So Godot works using node trees. If we were to, we're going to create a 2D scene. We don't need anything fancy right now. And you can see if we create a child node, we've got this huge list of nodes we can pick from, right, within node 2D. And these are like parents and children as well. So node 2D is any 2D game object. All right. It has a position, rotation, scale, and skew. But inside of that, we also have collision objects, which tells us where something is. We have physics bodies, we have areas, we have, even within that, there's other options, right? You don't need to understand all of these. Godot always has documentation. You can always see what, the item does, what methods it can use. Um, you can always go from there if you need to. So for now, the root type, we're actually going to want to change this. You can go to change type, and the one we are looking for is called an area 2D. All right. Now what we know is that an area 2D does not have a shape, so it can't connect or collide with other objects. And it actually gives us a tip to add a collision 2D shape as a child to define its shape. All right. For now, we are simply going to give it a look. We're going to have it look like something. So what we're looking for now is called a sprite 2D. And this one, you can see, general purpose sprite node. It displays a 2D texture. The texture displayed can be a region from a layer atlas texture or a frame from a specific sprite sheet animation. All right, so we'll select sprite 2D. Actually, we're going to create another folder. And this is going to be our scenes. We're going to create a scene folder. And this is where all of our scenes are going to live. Now, we don't actually need multiple objects because we've already defined multiple data. So in scenes, we're going to save this scene now. We'll just go up, up, and now we've got scenes here. And we're going to call this a merge item. And save. All right. So now we are going to tell this how to behave. So to do this, we're just going to come up here and we're going to attach a new script. All right. We're going to keep all of our scripts together. So we'll go to script and we're going to call this time just merge item. And this is going to be the behavior we assign to it. And don't forget to set this as C#. Okay. And create. Okay. Now we're back here in our Visual Studio editor. Okay. Now the way that we are going to, again, normally in coding, you'd have this all together anyway, but we're going to make it where we can drag and drop in the item data. For our, to give it what we call properties. Okay, now that we have the data in here, we're going to rely on an important function that tells us what's going to happen as soon as this comes into being once we start our game. And we call this function ready. Okay. We don't need that. We're going to be creating our own ready function. So what we will do is if there is data for this object, so this exclamation point equal means does not equal, and null means nothing. So if data is not nothing, then at this point we can go get node sprite 2D And that's the name of it. Dot texture equals data dot texture. Now what we're telling this sprite 2D node is that we wanted to have the data that we defined in merge item data. Right? Okay, so let's go ahead and save that. Okay, now before we get into its behavior, let's just see what this does in the editor. We're going to save this scene. We're going to create a new scene. And we're going to just be calling this, later on we're going to be setting up a board where all of these items are going to exist. So for now, we're just going to call this board. And the board is, I'm just going to set that as a 2D scene for now. Okay. Now what happens when we drag this merge item onto the board? It's invisible, right? We don't know what it looks like. And this is where data injection is really handy. You can see in the editor, we have this spot that says data. If we just drag meat level 1 data into this, we drop it. What happens when we play the scene? It's still invisible, right? Let's press the play button. You're going to want to do run current scene, by the way. This play button will run the project and it will make you define board as your main scene. And we don't want to do that yet. If you do it, it's okay. We can change it later. But for now, just do play current scene. Now we got to shrink it down, but see, now it has this icon. All right. And the reason it does that is because we've set its behavior. We've told it once the game starts, if there's data attached to this, we're going to use the data and we're going to set this node. We're going to give it the texture defined by it. Now, the reason it was so big is because the image files are big. I'm actually going to go and I'm going to fix that before you guys get the download. So you're not going to have to worry about that. I'm going to fix it off the camera, so don't worry about it. Okay. Now, again, if we were to run the scene, the bacon's here, and I fixed it, by the way. The bacon's here, but you can't drag it around, right? And so this comes into the next part of having any sort of class, is we need to teach it how to behave. We do that with what we call methods. Methods are essentially the object's behavior. So again, you don't need to fully understand what we're typing. You can mess with it on your own time. I will do my best to explain. This is going to be an input event. This is another thing that is built into it. You can see it references the base input. We are overriding this, and now we're telling the object what we want it to do with the input. All right, so the first thing we're going to want to do, and I'll do this in pseudocode first, is we're going to check if the item is clipped. All right, if it has been, if it is, then we will pick it up. Okay. And if it is being held, and if it's being held, we are going to tell it it's being dragged. Okay. If we put it down, we will tell it that it's not being dragged anymore. All right. So to type all this out, we're going to go if the event is input event mouse button mouse event, and that mouse event is pressed that mouse event is the button index of the mouse button dot left. Then we get into our other details here. Okay. So if that mouse is being clicked, then we're going to say if the mouse event is pressed and the mouse is over the player or the object, then we're going to do something here, and it even suggests it. We're going to use what we call a debug message. We're going to do gd print item clicked, and we'll give it the item name. All right. Okay. And there's one other thing we're going to do before we test this. You can see we get this red line here that says is mouse over, and it says it does not exist in the current context. Now we can manually create it, but if we go to this little light bulb, we can actually go to generate method is mouse over. Click on that. This line here, it's just so we basically, if we call it, it will say, hey, this doesn't exist yet, but at least we could run our code. Right? This is going to be a little more complicated. What we're going to do is we're going to get the vector2, and this basically just tells us the x position and the y position. We're going to get that for the local mouse position, and we're going to convert it to a local get global mouse position. You can see that's already built in there. The sprite 2D sprite And now the reason it is still red is because it always wants this Boolean return value. All right. Okay. So all that this code does is it tells us where the mouse position is. It tells us what sprite we're looking at, and we're checking the sprite size. All right. And then if the sprite has within it this location that the mouse has, it's going to return true. So now this kind of makes sense here. If the mouse is being pressed and it's true that the mouse is over, then we're going to say that the item has been clicked and list what the name of the item is. So let's go ahead and save this, and we're just going to test it and see if it runs. Okay. So here we are on the board. We know that we've got our item here, and we're going to run this program. All right, so we've got the bacon here. And right now, down here in this message window, when we click on it, we should see item clicked bacon. Okay, now it doesn't drag yet, but this is good. This means that it's sensing our mouse position. We can click somewhere in its vicinity, and we're going to see that we clicked on it. All right. Okay, let's add to this behavior a little bit more. So at this point, we're going to select that the item is, well, first we're going to create another variable up here. And this variable is going to be whether or not it's being currently clicked, whether or not it's being dragged. Okay, a Boolean is a yes or no. We're going to set is dragging. And the default for that, before we've done anything, is that it's false. Right. So once it's being clicked, we're going to set that value now to true. So is dragging? It sure is. Now, maybe it's not dragging yet because we haven't moved it yet. But what this does is it tells us that we can start doing that. One other thing I want us to do, and this matters more later, but we're going to do it now, is the z-index, which is essentially how far towards the player it is. We're going to want to bring this to the front because we don't want to be dragging it and it ends up slipping behind another object. We want to clearly see what we're dragging. And so it suggests 1. We're going to go a little overboard. It doesn't hurt. We're going to go to the z index being 10. All right. And it's always good to have some comments in here. Okay. Now, if the mouse is over it, sorry, if it's currently being dragged, and we are not clicking on the mouse, so I can type, then we're going to set this is dragging equals false. It's not dragging anymore. And the z index back to 0, right? So now it's on the same playing field as everybody else. Okay. And this is where so now we've done all this pseudocode. We've already put that in. All right. So we've got two methods here. We've got the ready method, what happens when the program starts. We've got the input method, what happens when we click a mouse, press a button. And now we're going to have another method that is essential for almost everything. This is the process. Okay. This double delta up here, delta is how often this occurs. So what this is going to be is every 60 frames per second, if that's the rate your game is running at, each frame of the game, this process is going to run. So this is almost like a constant check, right? So each time the game runs, we're going to check, is the object currently being dragged, right? And if it is, we're going to update its position to follow the mouse. Okay, so it already knows, again, it already knows what we're getting at, right? So we're going to set its global position to get mouse position. All right. So again, every time the game refreshes, which it's doing 60 times per second, it's going to check, are we dragging it, which we've introduced up here. And if we are dragging it, we're going to bring it with the mouse. Okay, so this is the very simple drag and drop feature of this item. So let's go ahead and save, and we're going to try to run it. All right, moment of truth. Here we go. The item is now draggable. As long as the item is being clicked and our mouse is moving, the item will attempt to follow it. Okay, we've let go. It's no longer being followed. Because we built a single class, now we can spawn as many objects as we want, right? Now we have that basic behavior. We can create as many of these as we want. Now, the reason why we separated the data from the object is because normally we'd have to create a meet1, a meet2, etc., and we'd have to drop these in like that. But at this point, all we have to worry about, and we're gonna change the name of this to the merge item so that it's easy to tell. Here on our board, we're actually going to delete this one. Now there's only one merge item we got to drag in here. And depending on what the merge item is based off of the data that we drag. So we can create a bacon. We can create another merge item, and we can make this one our sausage. And another merge item, and we can make another bacon. Okay. Now when we run the scene, here's our items. You can see our debug message. It even picks up on the item name. Okay. Now we would never use, and see now they're following it together. If I did the same with sausage, now it's picking up on that. That's not behavior that we want, but the way we design the game, that's not going to be an issue moving forward. All right, so thank you for tuning into part 2. Some important topics we covered. We covered what's a class. A class is that blueprint for whatever we're working with. The object is the actual instance of that, or the specific example of that, rather. Right, so blueprint is a car. The object is a Ford Fusion 2018. And this actual game object, we call this instantiation. We've instantiated it. The instance of the 2018 Ford Fusion is my car that's sitting out in my driveway. All right. So the other topic we've covered is we've started kind of touching on scalability, the concepts that we don't want to have to change things in multiple places. We don't want to have to redefine things in multiple places. We want everything to be defined once and carry over where it needs to be. We also learned about folder structure so that everything's contained where it's supposed to be, and we don't have to worry about other things being in other places, spaces. We can just focus on what we need to look at. We can just focus on scripts. We can just focus on scenes. We can just focus on items, etc. All right. So stay tuned for part 2, and we'll see you then.